Hello everyone, I am Lakshmi, Department of Mathematics, SNS College of Technology. Today I am going to present numerical solutions of ordinary differential equations in this topic, Euler's method. So it comes under statistics in numerical methods paper. So first we can recall some examples based on this. So here I chose the Fibonacci sequence. We know that Fibonacci sequence we add one by one, that stage by stage, we first value plus second value, that 3, 1 plus 3, that stage by stage, one by one we add the sequence and we get the sequence. It's a Fibonacci sequence, and based on it's a very basic example for this method, and we can move on to the dt with Euler's method. So dt with Euler's method, I mean, and basically design thinking approach having that 5 stages: empathize, define, ideate and prototype, test. So in this 5 empathize stage, students struggle with complex exponential forms. So the exponential forms, that means e power ix in that form, hard to understand the visualizations. And in the defining stage, we need to simplify the representation. So here that simplified representation of this e power ix is in terms of sine and cos. We can write these equations. After this, Euler's formula. In third stage, Euler's formula. We are ideating that formula. So using Euler's formula, we are bridging the bridge between e power ix and cos x and sin x. The formula is e power ix equal to cos x plus I sin x. We can go for this formula. So this formula, based on this formula, we can move on to that. This formula is derived from Taylor series. So once the formula is ideated, and we go for the prototype type. Prototype is that build the series step by step process, and uh, first level, first order, second order, third order, fourth order, step by step process. We can go for that. The final stage is test, compare with the actual values. For example, that unit circle we can choose. So here we choose that unit circle, and in this here actual cos x plus I sin x and Euler series approximations both are defined using and that straight line and the dotted lines. Okay, so it's a basic example for the that is a real world applications of this Euler's method. Here in this statistics and numerical methods, and we are using that Euler's series. Here series we are using, that series is based on the first order ordinary differential equations, and it has the form y dash equal to f of x comma y, and y of x, then we are choosing some initial conditions, y of x not equal to y naught, and there's some basic ideas we can discuss. So Euler's method approximates the solution using the tangent line this at each step. From the current point xn comma yn, move forward by step size h, that is yn plus 1 equal to yn plus h into function of xn comma yn. So this is the formula we are using in Euler's method. So it's a forward difference method only. So it's a single step method only. Mostly we go for that. If we need, we go for the next step, next level, the next iterations level. Once the target is reached, we can stop up to that stage. So the algorithm for this Euler's method is, first we initialize that formula, that x naught and y naught values, and then we can go for this formula. We can calculate that formula using that formula, and then we can apply into this first we are initiating x naught and y naught, and then we are uh, defining that function value, and then we are in together we can apply in this form Euler's formula, and we get the solution. So if we repeat this process until that xn reaches the desired endpoint, and the one, then with the approximate solution we get. So this, it has some advantages and limitations also. So the advantages are simple to implement, it is extremely easy to understand and code, ideal for quick approximations and as a building block for advanced methods, and it has a low, but it has some limitations because it has a low accuracy and instability is risk factor is very high. And higher order improvements, that modified Euler, the next level means that next Euler's next level is high modified Euler Heinz method, that and all derived, and in this method the predictor corrector approach or we can use, and also the improved modified Euler also method also we can apply, and also in RK method also we can use this, we can use here. Okay, so next we can move on to that mind map. So Euler's method, we here what we did, definitions we discussed, it is based on the numerical first order method, and some forward differences is discussed, and the linear approximation using tangent lines only, we are indicating like a formula, and then some algorithms having error analysis, implementation, pros and cons, higher order alternatives, that and all we discussed here. So in algorithm, the step-by-step process also we discussed. So some assessment questions based on this Euler's theorems are given, and also some reference links are given to learn some more examples, some more case studies based on this method. Thank you.